Okay. All right, then let's take a look at this example right here. Now, some of these horizontal stretches and shrinks, you can see. Some of them you can't. We'll try and play around with this and do a couple examples where we're sure that you can. So this one says graph each function using the techniques of shifting, compressing, vertical shrinking, stretching, and or reflecting. Start with the parent graph and show all the stages. Make the right shape, then move it where it needs to be. That's kind of what we're after. So we're going to start with the parent graph here, and I'm going to blow this up just a tad. And I'm going to do the parent graph in black, and I'll do that dotted. So it's going to look like this. Okay, is this the right graph? Okay, let me ask it this way. Is this the right shape? This is the right shape. What's wrong with it? Okay, it's not in the right place. What does the 2 do? Okay, we need to take that graph and we need to move it up 2. So we're going to take every single one of those points and move it up 2. So really the most important point here is going to be the vertex, that corner right there. We're going to move it up 2. And we've got that shape right there. Now, if we wanted to be convincing and make sure somebody knew we knew what we were talking about, we're going to write 0, 2 for a point on the graph. And let's say I go to this point right here. From this point, I go over 2. How far would I go up based on that shape? I'd go up 2. So this would be 2, 4 is where that would go. Now, if I take this point and I plug it in, it works in the equation. So it's definitely on the graph. What if I went back 3 from the vertex? If I go back 3, that's going to give me an x-coordinate of -3, but then I'd go up 3, so what's my y-coordinate right here? 5. Okay? Good there? Again, if we have the right shape, then making points that are on the graph and moving it somewhere else isn't too terribly difficult. Let's take a look at this one right here and make sure we have this. First of all, I want you to take notice that this is written the right way because it's got a plain old x plus or minus something. We could put parentheses around that, but the absolute value serves as parentheses. So I've changed the x before the absolute value makes that v shape. Then I multiplied it by 3. Then I subtracted 1 from it. So let's figure out what each one of these things does. What does the -1 do? Okay, down 1. What does the 2 do? Left 2. And what does the 3 do? Okay, so vertical stretch. And we came up with a couple different ways that we could describe what a vertical stretch is. If we vertically stretch this by a factor of 3, what does that do to the graph? How did we describe that? Makes the points taller. So if it used to look like this, it makes those points taller. Or another way to describe it is the graph is steeper. Okay, notice I'm not doing this. Okay, I'm not moving horizontally. I'm making the points taller or making the graph steeper. With me there? Okay, so let's figure out where this corner is. If the original graph looked like this, and again, I'll do this one here. If that's what the original shape is, I want to take that shape and I want to vertically stretch it and then move it where it needs to be. So I'm going to vertically stretch it first. We'll do kind of an intermediate step. Normally I go over 1 and up 1, over 2 and up 2, over 3 and up 3. I'm going to go over 1 and up 3. I'm going to go over 2 and up 6. So this is what the graph looks like. Now, this is the right shape, but it's not the right final graph because it's not in the right place. So for it to be in the right place, I need to take that shape right there, that steeper V shape, and I need to move it left 2 and down 1. So I'm going to go left 2 and down 1. And again, keeping in mind that we figured out the shape, I'm going to go over 1 from that corner, from that vertex, and I'm going to go up 3. Over 2, and I'm going to go up 6. And then I've got the same thing on the other side. So I've got a graph that looks like this. So what I've done here is I've drawn some kind of intermediate steps, but this is the answer. I'm going to erase this guy right here. Does that blue graph, in comparison with the original black graph, does it look like it's been slid to the left 2 and down 1? And does it look like the graph is 3 times taller than it used to be, or 3 times steeper, if you will? Does that look okay? All right, any questions? Is this pretty easy? Take a look at this one. This is a different shape. This is a graph that we covered in 3.4. We had a quiz on that. Those are shapes that you need to know. Those need to be locked away so you can just recall them. The original shape looks like this. It's a square root graph. So 0, 0, 1, 1, 4, 2. The original graph looks like this. What does the 1 do? What does the 4 do? And what does the negative do? So we'll work backwards. What does the 1 do? Okay, left 1 unit, right? What does the 4 do? Okay, it is a vertical stretch. And what does the negative do? Okay, it's a vertical flip, right? So here's the correct shape, okay, or the correct graph, the parent graph. We're going to take this. I'm going to make the right shape. So all I'm going to do is I'm going to take this and I'm going to flip it upside down and I'm going to vertically stretch it by 4. So it's going to open this way. It's going to be kind of down here. And normally I'd go over 1 and then I'd go down 1, but I need to go, what does the 4 tell me to do? 4 times as far. 4 times as far as 1, so that's going to be 4. Now the next point, if I go over 4, I'd normally go down the square root of 4. I'm going to go down, careful, square root of 4 is 2 times 4, 8, negative 8. So it would be about right here. Okay? That is the right shape, but it needs to be moved to the left one. So I'm going to take the whole graph, every one of those points that I found, move that over 1, move that over 1, move that over 1, and this is the graph right there, that solid one. Now, identify this point, and this point. One of them is pretty darn easy. This one's negative 1, comma 0. What's this one? 0, comma negative 4. And this one? 3, comma negative 8. Okay, watch. Let's plug in a 3. First thing we do with the 3, add 1 to it. Square root of 4 is 2. Times it by negative 4, negative 8. That point is on the graph. No XY tables. We knew the shape. We knew what those transformations do to the shape, and we've got the right graph. All the important features. No math teacher in the world would look at this work and say, I'm really not sure if they know what they're doing. They could see it. Any questions there? Okay, let's take a look at this one. I'm going to give you about a 30-second head start. Identify what the graph is, what shape it is, and figure out what transformation has been done to this. There's the parent graph, right? X cubed, the cubing function. We studied that last week. All we need to do is figure out what these two things do to the graph. And this one is, what does the 1 do? Right 1, and the 2? Up 2. Now, kind of like when we were doing parabolas in 1010, if you keep track of like that middle point, and on a parabola, it's a vertex. Here, it's just kind of that central point, the point of symmetry, if you want to call it that. We're going to take that point and we're going to move it to the right 2, to the right 1 and up 2. So we're going to put it right here. And then I'm going to label a couple other points. I normally, from that central point, I normally go over 1, up 1 cubed. I normally go over 2 and up 2 cubed, so that's going to be up 8, so we're going to be way up here. I normally go back 1, down 1 cubed, back 2, down 2 cubed, so that's going to be down 8, and this is what the graph is going to look like. Can you graph those 5 points? Can you label those? This one's easy. 1, 2. What's this one here? 2, 3. This one? 3, 10, right? Because we were already up 2. If we go up 2 cubed, that would be 8 more, so that would be 3, 10. This one's going to be 0, 1, and this one's going to be -1, -6. Okay? Any questions there? Sure? Again, you could plug those in and you could see that they actually are on the graph. All right, let's take a look at a couple more. The next one says, are there any questions? Raise your hand if you think this is easy. Okay, all right, that's half to 2/3. That's not too shabby. Okay, write the equation for y equals x cubed if it's been vertically stretched by a factor of 4 and moved to the right 5 units. So our parent graph, our shape is x cubed, the cubing function. We want to vertically stretch it by a factor of 4, and we want to move it to the right 5. Give you a hint. Starts off with y equals. Nice. Justin, what do we do here?
Since it's a vertical stretch, it's 4, and then it's just x minus 5 cubed.
Okay, and that would have to go in parentheses, right?
Yeah.
That's it, right? Easy enough? Okay, take a look at the next one. You have some problems like this, and occasionally they've put stuff like this on the final exam. I'm not a huge fan of this because you get it in a certain format so you can identify horizontal stretches and shrinks, horizontal shifts, vertical stretches and shrinks, flips and all that sort of stuff. On these, the instructions are very specific. They want things done in a very specific order, okay? So in order to get it right, you've got to make sure you do it in that order. So we're going to start with this function right here. We're going to start with the square root function. We want to shift it down 3, okay? Reflect it about the x-axis. Now think about what reflecting it about the x-axis would do, okay? That would be top for bottom and bottom to top, okay? So that's a vertical flip. Even though we're involving the x-axis, we're flipping top for bottom. So that's a vertical change there. Then it's reflected about the y-axis, okay? Now, if I just take y equals the square root of x and I want to shift it down 3, I'd do y equals, Tylin? Square root of x minus 3. And it would be outside the square root. We make the shape and then we slide the entire shape down 3 units. Everybody with me there? Okay, so I'd have this graph right here. It'd be down 1, 2, 3. It's like that. Okay, now I want to reflect it about the x-axis or like vertically flip it. How do I do that? Put a negative out front. So my question for you is it this? Raise your hand if you think that's the answer. Okay, just to there. Okay, raise your hand if you think that to there we should do something different. Clayton.
It needs to be inside the radical?
If we multiplied it by a negative inside the radical, that would change the x. That would be a horizontal flip. Okay? Hang on. Yeah. Okay. Here's what we need to do. This is the function. It's kind of like you start over with each one of these instructions. This is now the function, and we want to take that function and we want to vertically flip the entire thing. So we're going to put the whole thing in parentheses. That's going to take this whole shape and flip it upside down. So then it would look like, you with me? Then it would look like this, something like that. Doesn't this look like the vertical flip of that little guy that we had there? Of the first shape, if you will. Okay, so now we're dealing with something that looks like this. 1, 2, 3. Looks like that, sort of. Okay, now let's deal with the last one. Then it's reflected about the y-axis. Then we take this shape right here and we want to reflect it across the y-axis. So that's right for left. Look which way I'm moving my hand. Right for left. This is a horizontal change. And in order to have a horizontal change, where do we put, horizontal flip, where do we put the negative? Inside the parentheses, okay? So this means this is the final answer. It's negative square root negative x minus 3. Now, if you don't believe me, and this is why I don't like these, okay? If I distribute that negative through, what happens when I multiply here? That's a plus 3. And wouldn't this be, there's the original shape, horizontally flip it, vertically flip it, and then slide it up 3 units. Same thing, okay? So as long as you keep track of the order that it's been done, in order to get these parts right, and they've put a few of these on finals in past years, and nearly everybody misses them because we normally don't say, do this, do this, do this. We normally say, hey, take this shape and slide it around. You know, you're given something that's kind of like the vertex form that you had in 1010 with a parabola, and then you graph something like that. So these don't come up very often, but it's something good to know. Okay, are there any questions there? Sure? Okay, then we're going to take a look at a couple problems that are either on your assignment or they're very similar to ones on your assignment. First one is number 52. So it says graph y equals 1 over negative x plus 2. 1 over negative x plus 2. Now part of that is really easy. What does the plus 2 do? Okay, that's going to be up 2. So we're going to take 1 over x and somehow we're going to move it up 2. What does the negative do there? Okay, now if I leave the negative right here, it flips it horizontally, flips it right for left, right? What if I slid the negative out front? Would that be okay algebraically to do? Is that okay? Yeah, it's okay. And then it would be like a vertical flip. Yeah.
Since that can be the same as having it up front, how do we know that?
They're gonna turn out to be the same. If algebraically they're the same, so let me do it your way. Let me do it as a horizontal flip. So here's the original one. Whoops. Let me do this in black. Here's the original one, right? Here's the reciprocal graph. Now here's what I like to do. I like to take care of any stretches and shrinks and flips before I slide it around. I like to make the right shape, make the right graph, and then take the whole thing and slide it where it needs to be. So I'm going to do this. Again, I'm going to change colors. Because we put a negative in front of the x, we replaced an x with a negative x, we're going to do a horizontal flip. So I'm going to take this branch on the right and flip it over here and put it on the left. Take the one on the left, put it on the right. So this green graph is now the correct shape. You with me? All I need to do is take that graph, and this part looks pretty awful. Let me have this come down and get something that looks about right. All I need to do is take this green graph and do what with it, Tylin? Slide it up 2 units. So let's keep track of where this point is. This point is at 1, negative 1. 1, 2, so that's going to put it right here. This asymptote was at y equals 0. Where is it now? Y equals 2, so it's going to be here. Did we change the vertical asymptote at all? Not if we just slide it up. That's not going to change an x coordinate, so it's just x equals 0. So the graph's going to come along here, hit this point and go down. If I took this point right here and slid it up 2, that's going to put me right here. And again, it's going to run along here and go like that. Now, let me erase some of this so we don't muddy the waters too much. Does that red graph look like we did a horizontal flip, switched the right for the left, and then slid it up 2 units? And could you figure out what those coordinates are? Amelia, did you have a question?
I was going to say, it doesn't really matter if you move the negative or not.
Right. I'll show that next. Is everybody okay? What point is this? 1, 1, and this is -1, comma 3. And if you plug those in, do they work? They do. Now, what's been pointed out here is it doesn't matter if I slide the negative out front. So if I did this, -1 over x, and then did +2, this is going to be a vertical flip of this graph right here. So look what happens. I'm going to take this, flip it up here, this, flip it down here. Because it has so much symmetry, it doesn't matter whether I put it out front or on the bottom. Okay? And then all I do is take the blue graph, slide it up 2 units, and I've got my red graph right there. Any questions? Sure? Okay. Okay, for 63, you're going to have instructions on problems like this that'll say, the graph of f is given below. Use the graph of f as the first step toward graphing each of the transformations. And it says label at least 2 points, so make sure you follow those directions on the new graph, and state the intercepts if there are any. Okay? So this is the shape we're dealing with to begin with. Now what I did is I copied this, I erased the graph, so the scaling is the same and all that sort of stuff. All we have to do is look at this and figure out, okay, here's the function f. My new function, capital G of x, is little f of x plus 2. So that graph, but instead of plugging in x's, we're going to plug in x plus 2. And this is where that whole idea of what does adding 2 to the x do to this graph? Due to the shape. Left 2. It makes the shape, it makes this exact shape 2 units sooner than it normally would. So we're going to take this graph, and every single one of these points is going to be moved left 2. Now, which coordinate changes? The x does. So I'm going to graph -6, -2. So that's about right here. -4, -2. This is 0, 0. Where is it now? -2, 0. 0, 2. And this one is 2, -2. So you've got notes that were done to scale. Does it look like we took that graph and slid it left 2 units? All we did was change it horizontally. Now, it says label at least 2 points, so I'm going to do this one here, -4, -2. Okay, there's that corresponding point right there. And I'm going to go ahead and I'm going to label the intercepts since you've got to label them anyway. This is going to be -2, 0. That one's a little ugly, but let's see if we can get it. It's not ugly because all we did is we took this point right here and slid it back 2, so this is going to be 1, 0. So there are 3 points labeled there. Probably ought to just label the intercepts, then we'd be done. Any questions? Did I miss anything on the instructions? The other intercept. We get kind of in a mode of, well, all they want are x-intercepts. X-intercepts are really important when we're dealing with these and dealing with functions in general, but we want to do the y-intercept also, so this would be 0, 2. So if I had to do this again, I'd probably just label the 3 intercepts and call it good. Any questions? Okay, let's take a look at the next one. What does this do? Vertical flip. If it's a vertical change, what coordinates change? The y coordinates. So this is going to be not 4, -2, 4, 2. Not -2, -2. It's going to be -2, 2. 0, 0. Nothing to change there. 2, -2. And 4, +2, right? Does it look like the same shape, just been flipped? Hopefully. Again, if I label the intercepts, in this case only x-intercepts, I'll have 2 points that we labeled, and I'll have the intercepts indicated there. Any questions? Sure. What does the 1/2 do? Vertical shrink. So again, I'll ask this. If it's only a vertical change, the only coordinates that's going to change are the y coordinates. So they're going to be half as tall, half as big. The graph's going to be half as steep as it used to be. So I'm not going to graph -4, -2. What am I going to graph? -4, -1. -2, -1. What about 0, 0? What happens with that? Yeah, there's nowhere to shrink 0, 0, so we're right there. 2, 2 becomes 2, 1, and 4, -2 becomes 4, -1. So this is kind of nice that this vertical shrink is right underneath the one up above it. Does it look half as tall as it used to be? Do the lines look half as shallow, half as steep? I guess would be the better way to say it. Okay, so you can see the transformation there, right? And why are the intercepts still the same? What's that? All we did was a vertical change, and if we're only changing the y's by multiplying them by something and they're already 0, there's no change there. Okay? Let's take a look at this one. What does the negative there do? Horizontal flip. So if it's a horizontal change, the only coordinates we have to mess with are x's. We take every x and change its sign. So 4, -2, 2, -2, 0, 0, -2, 2, and -4, -2. So here's our graph. We can compare that pretty easily. Looks like a pretty darn good horizontal flip. And notice when I write down the intercepts, one of them didn't change because it was still at 0. Can't stretch or shrink 0. But -3, we can, or sorry, 3, we can flip that and it would be -3. Any questions? Okay, now, this one's going to be kind of interesting because this is a horizontal shrink. Very good. Horizontal shrink. It's going to shrink which coordinates? X coordinates by a factor of 2. So all the x coordinates are going to be half the size they used to be. So -4, -2 becomes half of -4? -2, -2. -2, -2 becomes careful, -1. We're changing the x. Okay, it's a horizontal. Can you stretch or shrink 0? No, remember, it's the x coordinate that we'd be changing, but that would still be 0, 0. This is going to be 1, 2. And this one's going to be 2, -1. Sorry, 2, -2. 2, -2. Oops. Does that look right? Okay, look what's been done to this. If you look at this in a horizontal direction, it's like they took this graph and just squished it. Now, does that make sense? Can somebody tell me why it squished it, why it shrunk it horizontally when we multiplied x's by 2? That,
the same reason why when we like add 2, we go to the left hand, that's the opposite. So you think when you multiply it with bigger, but it just gets smaller.
okay, you're right, it does the opposite, and I'll take that for now. Can anybody think of why it would make this shape in from here to here, when over here it took from there to there? Very good. Okay, it took from -4 all the way to 4. It took 8 units to make it with the regular old x's, but look what we're doing with the x's. We're doubling them. We're making the shape twice as fast. So if you make the shape twice as fast, it's going to make that shape in half the time. See the relationship there? See why it's a reciprocal relationship? Okay. Any questions? Sure? All right. good stuff to think about. Go ahead and get busy on the assignment. We rarely have time in 1050 to work or ask questions or anything. So if you've got any questions on anything up till this point, next time we're going to do some story problems on 3.6. Go ahead and get busy on the assignment. If you've got anything from 3.4, 3.5, ask it now. If you're not clear on the parent graphs of those functions, make sure you get those figured out because we use those quite a bit. And then I would like 3.4, if you would remind me at the end, send them to the center and to the front like we normally do, and that'll be it. Okay, thanks.